Problem number 3, a closed box, square base, fixed volume. So since it's a square base, I can draw something like that. I always want to draw a picture. Square base means that the length and width of the base have the same measure. And then we don't know what the height is, but since it doesn't say that it's a cube, we have to assume that the height is going to be different than the length of the base and length of a side of the base. So it has a fixed volume. So we know that volume is, again, just like the cylinder we did earlier, the volume is area of the base multiplied by the height. And so we know that that's fixed at 12,000. We're going to need to have a relationship between the x and the y. So this is our relationship. We want to always relate the variables because typically in these kind of problems we want to get rid of one of the variables, substituting in for one so that we can express a function in terms of just one variable. So find a function for the surface area of the box. So surface area, we know that we know what a box looks like. So I like to draw the box in a two-dimensional way so that I can see the area better. So that's the area, that's the base, and then we have the top, and then we have 4 sides, and each of those 4 sides has dimensions x and y. So if you can picture that, x, y there, so we have the front and the back and the side. So x, y are the areas of all 4 of those sides. So that's the surface area. Think about it, three-dimensional closed box. We have 6 surfaces, and the surface area then would be 2 of the x squareds plus 4 of the xy. So that's how we find surface area without remembering a formula. We just understand what it looks like, and then we apply that, what we know. And it says express the surface function for the surface area of the box. Well, it doesn't say that, but what we really want is the surface area in terms of just one variable. So we'll let that variable be x. And so all we have to do here is substitute in what y is equal to using this formula or this relationship that it already gave us. That's why it gives us that information. And so we want to solve for y and divide both sides by our x squared. And so we have that relationship. So we can substitute that back in for y. So remember, we have 2x squared, the surface area is 2x squared plus 4xy, but again, instead of y, we're going to put 12,000 over x squared. And then simplifying this a little bit, we can cancel the x's, and this is where we get the rational function. So the surface area in terms of x, it will be 2x squared plus 4 times 12,000 would be 48,000 over x. And that is our surface area in terms of just one variable. So we could easily make more of a problem on this one and say something like what would the dimensions of the base be to maximize the minimize the surface area. That's what we usually want to do here, is minimize a surface area. So we have a fixed volume, try to minimize surface area, things like that, minimize cost, and so we can take this in a few different directions, but this is the most important part, is coming up with the function in terms of one of the variables.